Today, we're going to be talking about something that's pretty hot right now. We're going to be diving into the world of MLOps.
Oh, yeah.
And
It's
specifically,
a good one.
we're going to be looking at professional certifications
Yeah.
in this field.
Nice.
Yeah.
MLOps is,
If you're out there and you're thinking about maybe getting a certification in this space,
yeah.
this is the episode for you because we're going to be talking all about what it could mean for your career.
I'm going to teach you what is Kubernetes and why do we need it, and then how to work with it. Okay, so these are the things which I'm going to teach you: how to install, how to configure, and all. So here Kubernetes will bring you health, wealth, and happiness. So in order to understand how do we get it, health for you, employees, us, all of us, wealth for organization, happiness for both of us. How Kubernetes can help in this way. So if you want to know, you have to understand what is Kubernetes, what is the Kubernetes architecture, you have to install Kubernetes, work with the pods and deployment, and many more. So question is, what is Kubernetes? So in order to understand what is Kubernetes, you need to answer 4 questions. Where did it come from? What does it do? What does the name mean? And why do we have it? So basically Kubernetes is born in Google. Okay. And Google donated this product in 2014 to CNCF. CNCF is like a, you can say, latest generation of Apache kind of foundation, which govern all the cloud native applications. So this product has been written in Golang. This is an open source product. It's a freely available, and it's, you can see source code you can download from the github.com and so on. Some of the websites, Slacks, meetups, and all many things we have it. Now, where did it come from? So the if you track the Kubernetes origin, then you will find it. The Kubernetes DNA. I'm not saying that it's extension or next release. Kubernetes DNA is matching with Bog in Omega. So now the question is, what is Bog in Omega? So let me tell you, Bog or no, Omega is a proprietary product on which the Google is running their services. Mind it, one of the fastest web services of Google, which is highly scalable, highly available, secured. It's running on Bog and Omega. So something similar Kubernetes can do as well. Okay. So that is something which we have Kubernetes. DNA is matching. Okay. In shorts, we call it KATES. And this, the keyword has been taken from the Greek word, which is called helmsman. So helmsman, the person who steers a ship. So here, the person who steers the ship. So here, understand this way. You have a fishing boat. The size, it can be small fishing boat, or the maybe petroleum vessels or aircraft carrier. Still, that is managed by one person, right? Irrespective of the size of the boat. But when it comes for data centers where you are running all of your applications in the containers, so you have thousands and thousands of virtual machines you have, and that is still handled by the one application, and that's called Kubernetes, and that's the reason they named it Kubernetes. So this Kubernetes can manage entire data centers irrespective of the size, and all thousands of servers can be managed by Kubernetes. So yes, it's born in Google, donated to CNCF in 2014, open source product. First release has happened in July 2015 and many more. So this is the question about the what is Kubernetes. But why we are learning actually Kubernetes? Why do we need this? So one of the problem which we have is like containers bring scalability challenges. Yeah. So containers mean Docker. By the way, we have a many container runtime environment, but most of the time we start with a Docker. We have a container D, Cryo, Practi, Rocket, many containers runtime environment we have, but we use Docker a lot. So here container has a certain problems, and that is called scalability challenges. What does that mean? So we love containers. We want to run our application in a container rather than virtual machines. And you know that. But the problem what we have is the moment you start scaling the containers beyond the host machine, then that is where the challenges started coming, because if you want to run the containers in the production, you have to run not only 5 container or 10 container, you have to run thousands of containers, right? So that is where the problem started coming. So now if you see this image here, this is the Docker architecture image, and here we have informations which includes like Docker can manage network, container, image, and volumes. That is the Docker can do that, and this is the architecture which we have. So here Docker client talk to the Docker host, and Docker host get the images from the registry and then create a containers accordingly. So this is the architecture, and that we are aware of it. But what is the challenge then? So here you think in a very simple way. Now, let's say you are using containers and you have in this image, you have a 5 servers. So let's say you want to, for the production, for the traffic, let's assume you want to run the 15 containers for the traffic. But each server can host up to the maximum three containers only. So what you would do? So you say simply yes, let's add a 4 more host. So that way three containers you can run in each of these, and then you will have a 15 containers altogether, which will be fulfilling our requirement. So that is the things you will say. But the question is, who would manage? Because Docker manage a container, which we discussed in the previous session. But the question is, who would manage this multiple Docker host? In a data center, if you look at this, you have to run the container in thousands of hosts. Each host will have let's say 10 containers. So Docker manage the container in each host, but who will manage the entire number of hosts? Docker host. That is a question. That's a challenge. Now, second thing is networking challenges. Okay. Networking challenges, like if you have a little bit of knowledge on the networking side of Docker containers, then we know that Docker, if you are running the container with the Docker, so if you want to access that container from outside, then you'll have to expose to the certain port of the node, correct? So here you cannot expose 2 containers at the same port, because you know that's a limitation of the Docker. So that means whenever you start running the containers beyond the number of hosts, multiple containers you want to run in the same host, that there are some certain networking challenges also there. So how do we deal with it? How to load balance multiple containers running with the same port in one host? That is the second challenge what you have. Third challenge what we have is Third challenge what we have is containers bring scalability challenges. Okay, just a second, give me 2 seconds. Sorry. So here, what we have a problem with. So here, in order to run, in order to run, uh, you know, traffic. I mean, whatever the traffic you are getting to your website, you want to run 15 container. Let's assume. So that will fulfill your traffic requirement. But because of some reason, 2 nodes are down, maybe hardware issues, network issues, software issues. So 2 nodes are down. That means 6 containers are down. So what would be impact? Impact would be your response time for the application for the end user will be increased. That is not good. Performance of the website will be decreased actually. So here we need 15 containers at any time, but 2 nodes is down. How do we do the auto healing? I said auto healing. So these are the some of the challenges which you get it when you want to run the containers beyond the number of hosts, 1 host or 2 hosts, because you have to run it in the production. Then lots of challenges coming like networking, load balancing, scalabilities, and many more. So these are the some of the challenges which we have. So now how do we fix it? Because Docker has certain limitation. Docker has not given any as such features which can manage the multiple hosts or to solve the networking problems and then auto healing capability. All this thing has not been given by Docker. So what to do now? So that is where the Kubernetes is coming, and Kubernetes will solve all this problem which we discussed, some of this problem which we discussed earlier. So Kubernetes can manage it. Are you able to understand this, all of you? Any questions? Any questions?
Can you explain last point?
Yeah. So here, so let's say networking problems. Who will solve it? Kubernetes will solve it. You want to run the fundamental objective is very simple. We want to run containers in the hundreds of boxes, hundreds of server. Why? Because in the production. So we need some platform which can manage all this thing, and that is important. So Kubernetes can manage it. Got it? So now you also have to understand the pets versus cattle. So pets versus cattle means what? So you have to understand this way. In Kubernetes, it's all about the cattle business. Let's say you are the owner of pets. So what happens? You just play with the pets. Something goes wrong. You try to take it to the doctor, feed them, play with them. So these are the things you do. That you give the special treatment to the pets. But cattle's, let's say you are a business owner of the cattle, so you don't worry about that. If few of the cattle is not working well, you replace the cattle with the new functional cattles and then deliver the milk, whatever it is. So here in the same case, Kubernetes will help you to help you in a cattle business way. That means, let's say if you say, hey Kubernetes, give me hundreds of containers, Kubernetes will give you hundreds of containers, not 99, not 101 also. So that is the kind of environment you will have it. So here, when you are learning Kubernetes, main objective to run thousands of containers in a cluster. That's your objective. If some containers are not working well, replace with the new container. That will be done by Kubernetes to make sure actual number of containers must match with the desired number of containers. So that is the major functionality of Kubernetes. Are you understanding, all of you?
Yes.
So what is Kubernetes? So Kubernetes is a container orchestrator. Kubernetes is orchestrating the container, or container orchestrator means, just now you asked this question, right? So orchestrator means you are running the container in hundreds of boxes. Who will manage it? Kubernetes will manage it. Now workload placement. What does that mean? Workload placement means in a data center you have hundreds of boxes. So where the containers will run, who will decide which node the containers will run? So that will be done by the Kubernetes itself. All the complexity will be hidden, like a networking challenges and all will be hidden, abstracted by the Kubernetes. And Kubernetes will also help you to manage the desired state. That means, in a simple way, if you say, hey Kubernetes, give me the hundreds of container, it'll give you hundreds of container, not 99, not 101. So these are the benefit of Kubernetes. Kubernetes also has a self-healing capability. So something goes wrong, automatically it will fix it. It has automated rollbacks, automatic auto scaling, load balancing features, and many more. So in a nutshell, if you want to run containers in the production server, whatever the challenges you have, whatever the feature you need it, you have at Kubernetes. Okay. Some of the benefits of using Kubernetes, which includes speed of deployment. That means you want to deploy the Kubernetes container, thousands of container within a second. Kubernetes can help you. You want to upgrade that thousands of container in seconds. Kubernetes will help you. You want to roll back the containers to the older version. Kubernetes can help you. And all the complexity will be hidden in the cluster only. So these are the things. Apart from that, not only Kubernetes is giving all this functionality, but also can help you to storage orchestration orchestrations as well. It can manage your secrets also. It has a self-healing capability, automated rollout and rollback, service discovery features also there, and load balancing. So basically, in a nutshell, if you want to run Kubernetes, so if you want to run container at the production level, then Kubernetes can help you in an end-to-end solutions. Are you able to understand this, all of you? All of you? Hello?
Yes, yes.
Okay, so now you have understood what is Kubernetes and why do we need it. Now we need to understand how the Kubernetes works, okay, architecture of it, how the Kubernetes works. So here we need to discuss about the architecture, okay. So now let's discuss about the architecture. So in the Kubernetes architecture, you have a one cluster, okay. And if you look at this here very carefully, in a cluster, you have a multiple virtual machines. It can be physical machines also, but nowadays we have a virtual machines. So here you have a two kind of machines. One is worker node and another one is master node. Okay, that means in a Kubernetes architecture, you have a Kubernetes cluster. In a Kubernetes cluster, you have worker node and then you have a master node. So both of these machines working together to become a cluster. Now, if you see that there's one package which is coming from outside and sending to the master, and that package is being generated by you as an administrator or user. Okay, so that means if someone will ask you, hey, what is the architecture of Kubernetes? So you say you have a master server, and then we have a worker server. Master server which manage the cluster, and the worker server where the containers are running. Worker server, you can call it a node also, you can call it a minions also. So many names are there. So clusters will have a master node server, worker server. Master server manage the clusters, worker server run your containers. Now who get an instruction? How do we get the instruction from outside? So you write some packages, YAML or JSON file, and send it to master, and master get your work done with the help of work. So that is the architecture. So here, so Jamie, I just muted you. Okay. So here, so master server, which is in charge, and the worker server will do the work. Work means what? Whenever you see work, worker is like running a container. Work is equal to container. Okay. That is important. So here you see in this image, in the node, each node, worker node, you see there is a pod. And inside the pod, you see the icon, which is a container icon. So that means in this image, it looks like the container you cannot run in Kubernetes directly. So you have to frame it within a pod in Kubernetes. So that is important to understand. That means container is running inside a pod. That means you deploy the pod and pod get a containers. Mind it. So now let's discuss about the master server. So what is a master server? So master server always has to be Linux 64-bit. Okay. And worker server can be Linux and can be Windows also. So master server, how can you set up a master server? So in order to set up a master server, you have to set up a 4 software in the master server. These are the software which we'll discuss. Master server which manage the entire cluster. So if one master server is down, your entire cluster will be down. That is not a good sign. So you can have a multiple master also, multi-HA master, so we can set it up. Okay. Now, if you look at this image here, master server, you can configure by installing and configuring 4 software, has to be Linux, and master server manage the lots of worker server. That means these are the VMs. Now, if you look at this here, in the node, you have a pod, and one pod you may have a multiple container. Right side, if you see in a node, you have a multiple pod, and each pod you have a one container. That means what I'm trying to say here is, ultimately, if you want to run a container, it will be running the worker server. Okay, and then in worker server you have a pod. You may have one pod, you have a multiple pod. In each pod you may have a single container, you may have a multiple container. So that's a scenario. Okay, so remember that. So now the question is, okay, how do we set the master server? How do we configure the master server? What are the things to be done in order to set up a master server? So here we need to install the 4 software. One is API server. Okay, that will be the kind of front end. Okay, that's the one software which all the traffic received, all the request in the cluster received by API server only. That's the first software. Second software is etcd. Okay, cluster store. So cluster store is like a kind of database. The values are stored in the key and values format. And then third software, you have a controller manager. Okay, and the fourth software, you have a scheduler. So these are the 4 software, 4 applications. You need to install it in order to make a master server as a master. Okay, so this is something which you can do that. Okay, so if someone will ask you, hey, tell me the architecture of Kubernetes. So you say we have a cluster. In a cluster, you have master server and then worker server. Master server, we have primarily four software: API server, cluster store, controller, and scheduler. And the worker server also we have a few software. What is this software? Let's discuss about it. This is the worker server. Okay, in the worker server, first software which is a kubelet. Okay, so kubelet is basically the agent which is installed and running in each worker server. Mind it. So this is the kubelet. Second one is Docker. It can be Rocket and other things also. It can be containerd also, cryo also. Many options are there, but Docker is the most popular one. So second software has to be there, Docker, and third one is a kubeproxy. Kubeproxy is the networking services which solve the container networking. So these are the three software you need to have in the worker server. Okay, so now you see that this is the complete architecture. If you see that, you will talk to API server, request saying that, hey, I want to deploy hundreds of containers. So that request will be stored in the etcd, which is the database, and controller manager will say, hey, we have a 0 container. So then API server will make a request to the scheduler, go and schedule the hundreds of container. Now here kubelet, which will talk to API server, receive the request, and kubelet will talk to the Docker to create a container. So kubelet will create a pod, and then Docker will fill the container inside a pod, and then networking will come from the kubeproxy and update the IP table. So this is the overall component of your Kubernetes architecture. Are you understanding, all of you?
Yes, yes.
Yeah, so this is the architecture you have to buy hard. If someone will ask you, you have to update this one. This arrow sign is very important, so you have to take it further. So these are the three components we have in the worker server. So now how this inter node communication happens. So you see here, kubelet to talk to API server, kubeproxy talk to API server. So here, these are the four components you have in the master server, and these are the three components you have in the worker server. Please remember this image all the time. There are few more components which we have in the master server, but that's not so important. Okay, so these are the architecture image. I'm ignoring it for time being. Okay, so now you understood that this image, if you look at this, here you have a master server, here you have worker server, and the worker server you have to deploy the pod, and the pod you have a containers. But the question is, how can you make a request to API server? So you have to make a request to the API server from your workstation. That's called workstation. Remember, this is the master, this is worker, and this is the workstation. Now the question is, how do we configure the workstation? So in order to set up workstation, you have to install the kubectl in your laptop. Okay, look at this, kubectl is there in your laptop, and then you have to write a JSON file, a YAML file, and inform the kubectl, hey, just create update. It's API server, remember, API call. So create, update, delete, or read anything. So you'll send this YAML file or JSON file to API server, and API server will store that whatever the request you have in JSON format, in YAML format, it will store in the cluster store, and then controller will keep reporting what you have, and scheduler will schedule the work to the worker node. And the worker node, you have a kubelet, and then Docker and proxy, and which will manage your pod and container. So now the important thing is, see, cluster setup is not that great. It's just a few minutes of work. But the important thing is what you are going to request it. Let's say you have a cluster and you will configure the kubectl. So what you are going to request it, and that is important. So here we are going to write a JSON and YAML file for it. So in a JSON file or YAML file, you will describe what you want. What do you want? So here you say, I want 3 pods of Nginx, and you got the 3 pods. Simple. Okay, so clusters will get you the three pods, and these all 3 pods are running the different worker node. Now suddenly one node is down. What will happen? So desire was 3 pod. actuals are 2 pod. What will happen? Immediately, Kubernetes auto heal this stuff, and they will replace the third pod in some workers, and then desire and actual is match. And that is what I said. No, Kubernetes has self-healing capabilities also. Are you understanding, all of you?
Yes, yes.
Yeah. So yeah. So what you want from Kubernetes? So the important thing, your primary objective would be to learn what you want from Kubernetes, because ultimately you have to write a JSON file and YAML file, and you have to specify what you want actually. So here I said I want pod, okay, but what else you want? So yes, there are so many objects we have in Kubernetes, and that's your main learnings. What do you want? Pod. What do you want? Controller. What do you want? Services. What do you want? Storage. And this is not the list. We have a lots of resources which you want, and your learnings will be spent primarily on this. What is a deployment? What is a replica set? What is a stateful set? What is a pod? What is a limit range? What is HPA? And so many. So your primary learning, once you configure the clusters, your primary learnings will be to explore all these options. Are you understanding, all of you?
Rajesh, what do you mean by storage here?
Okay, I'll put it in this way. Let's say when you go to the AWS, what are the different types of storage you have? So you have a object storage, you have a block storage, you have a file storage, all this thing, right? Correct now?
Yes,
So
yes, yes, yes.
similarly, Kubernetes is a platform for the Kubernetes runs your container in a pod, but they need also storage for that to make the data persistent. So that is where that storage orchestrations also has to happen. Different types of storage are also supported in Kubernetes, and that is coming under the storage section actually. So here Kubernetes can help you in many things actually. Kubernetes will run your container in the mass scale. Kubernetes will solve your networking problems. Kubernetes will help you DNS problem. Kubernetes help you auto scaling. Kubernetes will help you in terms of self-healing. Kubernetes will help you to manage your orchestration for storage. Kubernetes will help you in terms of managing your microservices. So many things you have. In a nutshell, if I tell you, without a Kubernetes, you cannot survive in this IT industry from this year onwards, because everyone has migrated to the Kubernetes. The VMs, no one is running the software nowadays in the virtual machines. Everyone is running on the containers with the help of Kubernetes. There is no alternative of the Kubernetes as well. So it's like a market dominant. Make sense? Okay.
Yes, yes,
So
got it.
So I wanted to cover what is Kubernetes, and then why do we need a Kubernetes, how Kubernetes works, which is like architecture and all, and so on. So next topic would be what are the resources which we will set up a clusters, one set cluster, and then these resources which you can see on my screen, we will learn one by one.